According to the National Electrical Code, specifically the 2020 edition, Section 300.3b, it is not permissible to tap a single circuit to supply multiple branch circuits. This means that in the situation described, where there are two 208-volt single-phase 30-amp counter-mounted cooking units in a commercial kitchen, it is not code compliant to run one 60-amp circuit or junction box located 80 feet away from the panel and then feed each cooking unit from the junction box. The relevant section of the NEC, Section 300.3b, clearly states that conductors shall not be tapped for a branch circuit. This fundamental rule dictates that each branch circuit must originate directly from the electrical panel. The intent of this regulation is to ensure the integrity and safety of the electrical system. Tapping a circuit, as proposed, introduces several potential hazards and compromises the intended overcurrent protection. When a circuit is tapped, it becomes difficult to accurately determine the load on each segment of the circuit. This can lead to overloading the conductors and potentially causing a fire. Furthermore, the overcurrent protection device, such as a circuit breaker or fuse, is designed to protect the entire branch circuit. When the circuit is tapped, the overcurrent protection device may not be able to effectively protect the individual segments of the circuit, especially if one segment experiences a fault or overload. In the scenario described, each of the 30-amp cooking units constitutes a separate branch circuit. Therefore, each unit requires its own dedicated circuit originating from the electrical panel with appropriate overcurrent protection size to protect the circuit conductors and the cooking unit itself. To properly supply the two 30-amp cooking units, two separate 30-amp circuits, each running directly from the electrical panel to its respective cooking unit, would be required. Each of these circuits should be protected by a 30-amp circuit breaker or fuse. The conductors must be sized appropriately for the 30-amp load, taking into account factors such as conductor type, insulation rating, and ambient temperature. The NEC provides tables and guidelines for determining the appropriate conductor size for various ampacities. For example, Table 310.16 in the NEC provides the allowable ampacities of insulated conductors rated up to 2000 volts, based on the conductor size and insulation type. It is essential to consult this table and other relevant sections of the NEC to ensure that the conductors are properly sized. In addition to conductor sizing, it is also crucial to consider the voltage drop in the circuit. Voltage drop occurs when the voltage at the load is less than the voltage at the source due to the resistance of the conductors. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting the voltage drop in branch circuits to no more than 3%. To minimize voltage drop, it may be necessary to increase the conductor size, especially for long circuit runs. In the described scenario, where the junction box is located 80 feet away from the panel, voltage drop could be a significant concern. Therefore, it is essential to calculate the voltage drop for the proposed circuit configuration and ensure that it is within acceptable limits. There are various online calculators and software tools available that can assist in calculating voltage drop. These tools typically require information such as the conductor size, conductor type, circuit length, and load current. When installing the circuits for the cooking units, it is important to follow all applicable NEC requirements and local electrical codes. This includes proper wiring methods, grounding, and bonding. All electrical work should be performed by a qualified and licensed electrician. Grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, allowing the overcurrent protection device to trip and energize the circuit. Bonding ensures that all metal parts of the electrical system are electrically connected, minimizing the risk of electric shock. The NEC provides detailed requirements for grounding and bonding in Article 250. It is important to carefully review and comply with these requirements to ensure a safe and reliable electrical system. In the specific case of commercial kitchens, there are additional considerations to keep in mind. Commercial kitchens are typically wet and damp environments, which can increase the risk of electrical shock. Therefore, it is important to use wiring methods and equipment that are suitable for wet and damp locations. The NEC provides requirements for wiring in wet and damp locations in Article 300. Furthermore, commercial kitchens often have high ambient temperatures, which can affect the ampacity of conductors. It is important to denote the ampacity of conductors in accordance with NEC Table 310.15 burn if the ambient temperature exceeds 86 degrees Fahrenheit 30 degrees Celsius. The NEC also addresses the installation of equipment in commercial kitchens in Article 220 and Article 430. These articles provide requirements for calculating the load on the electrical system and for selecting and installing equipment such as cooking appliances, ventilation systems, and refrigeration equipment. In summary, it is not permissible to tap a single circuit to supply multiple branch circuits based on NEC 2020, Section 300.3b. Each branch circuit must have a direct connection to the circuit panel with appropriate overcurrent protection. To properly supply the 230 amp cooking units, two separate 30 amp circuits, each running directly from the electrical panel to its respective cooking unit, would be required. It is also important to consider conductor sizing, voltage drop, grounding, bonding, and the specific requirements for commercial kitchens. All electrical work should be performed by a qualified and licensed electrician. The NEC is a comprehensive set of standards that governs the safe installation of electrical wiring and equipment. It is essential for electricians, engineers, and other professionals involved in the electrical industry to be familiar with the NEC and to comply with its requirements. The NEC is updated every 3 years, so it is important to stay current with the latest edition. In addition to the NEC, local electrical codes may also apply. Local codes may be more stringent than the NEC in some areas. It is important to check with the local authority having jurisdiction to determine the applicable electrical codes. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified and licensed electrician before performing any electrical work. Failure to comply with the NEC and local electrical codes can result in serious injury, property damage, and legal penalties. It is crucial to prioritize safety and ensure that all electrical work is performed in a competent and professional manner. One aspect to keep in mind is the labeling requirements. Once the circuits are installed, it is crucial to properly label them at the electrical panel. Each circuit breaker should be clearly labeled with the equipment it serves. This makes it easier to identify and troubleshoot circuits in the future. The NEC requires that circuit breakers be labeled in a clear and understandable manner. The labeling should be durable and resistant to fading or damage. Another important consideration is the use of arc fault circuit interrupters, or FSIs. FSIs are designed to protect against electrical fires caused by arcing faults. Arcing faults can occur when damaged or deteriorated wiring creates a path for electricity to flow through the air. FSIs detect these arcing faults and trip the circuit breaker, preventing a fire from starting. The NEC requires FSIs in many areas of the home, including bedrooms, living rooms, and dining rooms. While FSIs are not typically required in commercial kitchens, it is still a good idea to consider using them to enhance electrical safety. Another option to consider is the use of ground fault circuit interrupters, or GFCIs. GFCIs are designed to protect against electrical shock caused by ground faults. Ground faults occur when electricity flows through an unintended path to ground, such as through a person's body. GFCIs detect these ground faults and trip the circuit breaker, preventing an electrical shock. The NEC requires GFCIs in many areas where there is a risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. In commercial kitchens, GFCIs are typically required for receptacles that are located near sinks or other sources of water. Regular inspections and maintenance are also crucial for ensuring the safety and reliability of the electrical system. Electrical systems should be inspected periodically by a qualified electrician to identify any potential problems. Maintenance tasks such as tightening connections, replacing worn or damaged components, and testing GFCIs and FSIs should be performed on a regular basis. By following these best practices and complying with the NEC and local electrical codes, it is possible to create a safe and reliable electrical system for the commercial kitchen. Remember, electrical safety is paramount, and it is always best to err on the side of caution. When in doubt, consult with a qualified and licensed electrician. In the given scenario, the proposed configuration violates electrical code, specifically NEC 2020 section 300.3b. The correct approach involves running two separate 30-amp circuits directly from the panel to each cooking unit. These circuits should be adequately protected by 30-amp circuit breakers, and wiring should adhere to NEC standards, factoring in ambient temperature, voltage drop, and the presence of moisture. The importance of engaging a licensed electrician for such installations cannot be overstated, ensuring compliance and safety.